Today we're beginning a unit that focuses on mostly right triangles, but triangles in general are also going to be one of the things that we're going to be studying. This first page of the notes is to learn about side lengths that can form triangles and how to know if you're given a set of side lengths whether or not they can create a triangle. We're also going to be determining what type of triangle they make if they are able to form a triangle in one of the later videos. Right here though, we're just gonna, it's titled to be or not to be, and that's just talking about can it make a triangle or not. We are gonna use constructions to verify if a triangle can be formed with the given side lengths or not. You are not going to be tested on using constructions in this unit, but we are just using them to investigate on this page of notes. So it's starting with three measurements, 3 centimeters, 6 centimeters, and 7 centimeters. And I would ask that you kind of think for a moment and decide whether you think it might or might not make a triangle, even if you're just guessing right now because we haven't studied the rule yet. It's kind of a good thing to just think ahead about, do you think it's going to work or do you think it's not going to work? I'm going to be measuring with the centimeters on this protractor here. And how I'm going to do this is I'm going to start by putting the longest one on my paper, which is 7 centimeters. So right there, 7 centimeter segment on the paper. And we're going to see if we can make a triangle using a side. I'm going to put the 3 on this side and the 6 on this side. And I'm going to be using my compass to do this because I don't know right now where they would cross or even if they would cross. And so you're going to take your compass and you know that this is 7 centimeters on the bottom. So we measured that and placed it. Now I'm going to measure a 3 centimeter opening with my compass here, and I'm going to place that on one end, and I'm going to just swing that like so, and we're hoping that our sides will cross. I'm trying to go for a triangle above the line. The other side says 6, so we need a 6 centimeter opening of the compass. There we go. And finding where that will lead to. And so we know that this distance from there to there is 6 centimeters, and the distance from here to here is 3, and then the distance along the bottom was 7. We can see that they're crossing right here, and so that would form a triangle if we were to connect to the ends of our initial segment that we drew. And so this is 6 centimeters, this is 3 centimeters, and this is 7 centimeters on the bottom. And we can see that yes, it does make a triangle. And for this part of the page, that's all we want to know is, does it make a triangle or not? On question 2, we have 3, 5, and 8. So again, let's start with the longest measurement of 8. And know that, our measurement skills are not always the best, and so you may or may not get the same exact result that I get. So I've got 3 centimeters and 5 centimeters. And what should happen with this one, since the overall length is 8, and this is 5, and this is 3, the minute they lift up off the line, they're no longer touching. And so these are not creating a triangle. And this is the one that gets people the most, is when these are adding to the same amount as that. These do not make a triangle. there has to be, I call it overlap. When you put the 3 centimeter and the 6 centimeter here, you can see that they had this overlapping space. If they do not have any overlap, then they're not able to lift up and connect. That if they're not overlapping, the minute they lift up, they're no longer touching here. Or maybe they never even reach each other when you draw them on the segment, like this next one. We've got 8 centimeters for our first measurement they want us to put down. So that's 8 centimeters, and they want us to do 3 and 4. So I'm going to measure 3 from one end and 4 from the other. You can see that these never had any hope of meeting. We've got 4 centimeters here, 3 centimeters here. That only totals at 7. So with that 8 centimeter length there on the bottom, they never had any hope of reaching each other. They're just flapping in the wind out here. And there's no triangle formed when those are your side measurements. Next one we've got is 4, 5, and 7. So you can kind of think about 4 and 5. Those are the shorter ones. 7 is the longest. I'm going to put the 7 on the page first. And 4 and 5 from each end. And you can see that 4 and 5 are going to add to 9. And so that's more than 7. So there's definitely going to be some overlap with this one. And they should be able to form a triangle. There's the 4. There's the 5. And you can see they're overlapping right here, and here's where they're meeting. So they do make a triangle. So we've got our 5 centimeters here, our 7 centimeters on the bottom, and our 4 centimeters there. They do make a triangle, as they do have that overlap at the bottom there. So what has to be true about the lengths of the sides in order for a triangle to be formed? I'm going to write this in the way that the general rule is written, and then I'm going to mention kind of a shortcut for this as well. The general rule is written that any 2 sides must add to more than the third side to form a triangle. Now, if you're adding like the 5 and the 7, well, they're already more than the 4. So it's kind of silly when we know the actual numbers to be checking all 3 sums, meaning 4 and 5 add to more than 7, 5 and 7 add to more than 4. 4 and 7 add to more than 5. Those are all the combinations of any 2 sides. Sometimes we need that if we're dealing with algebraic expressions, but in the case where we have only numbers, I would suggest just checking that the 2 shorter sides must add 2 more than the longest. So if we have a way to know which ones are the shorter sides and which one is the longest side, and when they're numbers, we certainly do, then we only need to test that the 2 short ones add to more than the longest. So looking, 3 and 6 makes 9, that's more than 7. 3 and 5 makes 8, that is not more than 8. So there's no triangle there. 3 and 4 makes 7, that's not more than 8, no triangle. 4 and 5 is 9, that is more than 7, yes, triangle can be formed. There's another thing that I need to add off into the margin here, and that's sometimes we give you 2 measurements and we ask you for the possible lengths of the third